in this episode of Finno-Ugric Machining? We are going to see how I set up the workpiece into the milling machine table. That's one. And then we are doing some milling there. Yeah, okay. Before that, there was a suggestion that I should name that pony. Yeah, okay. But I let you decide what is the name going to be. I will giving you 5 alternatives and please choose one of those. The first alternative would be Pyry. Pyry. This is Finnish known for heavy snowfall. No wind, but it's raining quite heavily. That's Pyry. Then there might be some wind, but not a lot, because the next second alternative for this name would be Tuisku. And this one is associated, it's Pyry, but there is a lot of wind. So it's a horizontal Pyry. And then we have, a generic word for snow. This is now the third alternative, and this is a generic word for snow. It's lumi. That's snow. Generally, it can be any type of snow. It's lumi. Yeah. Okay. Then we have the fourth alternative, which is nuoska. Yeah. This means snow that is on the ground. It's not wet, but it is. It has a consistency that you can easily make snowballs out of it. It's not really wet, but it's sort of sticky. So that's nuoska. It's also heavy. You don't want to have a nuoska on your yard if you need to remove it because it's quite heavy. Okay? And then the last, fifth alternative would be nietos. Nietos is, you can meet this in the forest. It's very deep snow, waist high at least. It's very difficult to go into that thing because you sunk into it. And yeah, nietos. And at least from these 5 alternatives, please choose one. I put in the comments a sticky comment which you can then comment which one you like the most. Yeah. Okay, so one more time. Pyry, tuisku, lumi, nuoska and nietos. Those are, and why snow? Well, the color. Yeah. And in 3 months we are going to have one of those here in Finland. Oh yeah. Okay, so now let's go on with how to set up a workpiece into the milling table if you don't have a vise. We need now to attach this workpiece into this table. Reliably, straight and in a good place. Well, I'm using parallels here. Well, parallels like this. These are 10 millimeters wide and 20 millimeters high. And about the parallels, the width is not guaranteed to be even. The height is. So I use them this way. And now when you put your parallels on the table, of course, goes without saying, you have to clean up the table pretty well before putting anything on it. Yeah, that's quite important. And then when you put a parallel here, you check that the parallel is also clean, and it makes a specific sound when it's making a full contact. You can hear it, it's like sizzling. It's not rubbing, it's sizzling. And same here. If I now can find a place where it doesn't sizzle, well, I cannot find a place where it doesn't sizzle. Okay, then you have your parallels there. And then I put my workpiece on top of those parallels like that. And well, I have determined that this groove is in a very good place for us. And yeah, okay. The next step, before I put the clamps here, is to protect the surface of this workpiece by, well, I'm using copper pieces like this. And those I put here at the ends. Okay, and well, now I show you how I make these. That's, well, very easy. Well, for those copper pieces I use a copper tube like this. First I will take, well, let's see now. I have a tool like this. It has a rolling blade here. And well, this is normally what you use when you cut copper tubes. And then you put it like here somewhere. And at this point you determine how wide these become. And then you just rotate it around and tighten it while you rotate it. And at some point that tube just cuts off. Now it's very near. There you go. One. Put that material away, that one also, and now we have these nice little things which I just squeeze here in between. Well, just squeeze them. Put it there and then just hammer it flat. Don't hammer your fingers, that would be not very nice. Okay, we are ready with these. Okay, let's now use the new ones which we just made. They come to the ends here. And now we also need these guys. That is one part. Well, I usually put, I measure it, I know because I already made this, but let me show how I do this. Because you need to choose the suitable stud there. Well, let's talk about these T-nuts first. So, this is, well, it's a T-nut. And if you can see, there is some dings there and there. Well, I made those. This is so that when you put your screw here, it doesn't go past that point. That's, well, I don't know how many people have broken their milling table by having such T-nuts that you can screw through, and then you can tighten it so, without tightening your workpiece. You tighten it so that it will well, break your table. Yeah, okay. So what I do, at that point I usually don't have these here. I just put this here and then I drop it there. Okay, that's suitable length. Yeah, that's quite simple. Well, and then just let's put this there and that there. Now, well, these parallels, when these are positioned here, these should be made so that they are a little bit over the edge in this case. Then I know that I have enough room to drill my holes. Furthermore, I usually check by pushing at the corners that it doesn't wiggle. Yeah, this doesn't. So, now we have one piece here like that, and then we put this with the copper thing, we put it here. And now the orientation of this thing, well, I need to put it at the very edge of this thing to work correctly. This should be in such leveled in a way that it's not too high here or not too low. Well, it should be suitably so that this is about level. And of course the teeth here must go into each other. No chips in there between, etc. So they should be clean. Well, the next step is of course the nut here, like that. And I tighten it just very mildly by finger tight only at this point so that I can still adjust these. There you are. And then we rinse and repeat the other side as well. I tighten this one quite tight actually already. And this one just so that it doesn't lift up. No more. What I want is that it will be pivoting at this end when I try to straighten it. And then what I this you might think to be funny, but I usually put it a little bit already like tilted, so because it's easier to knock from this side than from this side. Well, let's first set up a dial indicator here. I'm using this. I have made this for this purpose only. This milling machine has these overarm supports like this. You can pull them out. Then I tighten it back to that place. There you are. And then I just put this into this hole. Like that. Well, maybe there. And then I tighten this here. And that's steady. And then I put my dial indicator here. Goes into that hole. Well, first, this side is now tight. Not completely tight, but very tight, quite tight. And that side is loose. It's really like almost in finger tight. And now, well, I go to this end. I assume it's pivoting about that point. And then I adjust the y-axis, this axis, so that we are at 0. Like there. And then I lock the table, the Y. And then I start dialing. And as you can see, this means that it's now lower. So then I knock here at the end, very gently. Okay. I knock a little bit more. Now I lift this because... Okay. I don't want to spoil my... Okay. We are very near. Actually, this is... Oh. Okay. Okay. Now that it is 0, I go back here. And you can see that it's still a little bit grouped. Well, it pivoted not exactly at that point, it pivoted from somewhere else. And so I need to 0 this again. And just rinse and repeat. Oh no, yeah, okay. Like that. Okay. Might. No. Then I go back here. Like here. And then I adjust the Y one more time. Now we have 2/100ths of a millimeter difference there. There you are. And then let's go. Well, I'm not sure whether this is I need to this needs to be knocked really gently. Oh, went out. And yeah, you always measure it to the same direction. Okay, now let's see the last and final time. I try to get this as precise as I can, and let's see now, it shouldn't move a lot. Well, 1/100. Okay. Let's take that away. There you are. And then well, it's a 0 here. 0. Well, it's done. 0 all the way. Now comes the critical part. You have to tighten those. And, don't do it, do it very gradually. So that it doesn't move. Well, this didn't move. Yeah. I can see that the needle doesn't move, and that's good. That's really good. There you are. That's there. Now a final check. It's 0, is it? Oh yeah, okay. I'm just knocking this to ensure that the dial indicator is really measuring something. And yeah, there you are. Yeah, okay, so let's repeat this. So when you want to straighten such a piece, do it so that you know where it is pivoting. If you do it like knocking it each and every way, you will be chasing your tail the rest of the evening. Yeah, but this way you get it, well, the maximum is absolutely 5 scans. Then it's, if it's not 10 straight, then the workpiece itself is somehow curved. Well, but as you can see, this is at least the surface is straight. Well, and I know it's perpendicular to the sides, and it's also parallel to the other side. Well, yeah, there you are. Now this workpiece is straight. It's either perpendicular or parallel with the milling table, however you think it. But we don't have the faintest idea where it is. It's it's straight, but it is just somewhere. And now I'm using this tool. It's Starrett. This is Edge Finder. Yeah, it's a thing that has. Where could I show it to you? It has a spring-loaded mechanism here, which goes like this. Yeah, there is a spring inside, and then we have two surfaces which are really well, they are really straight. And then we have this part here, which is the measuring surface. This is all hardened, and this one is exactly 6 millimeters in diameter. And the chunk of this is, it's 10 millimeters, and I have here, you didn't see it, but I have here, well, you almost saw it. I have here a 10 millimeter collet for that one. And now we go, I will measure this edge here first, the x-axis. So let's go there. And now how to set this up is that you go near the surface with this, like that. Somewhere there maybe. Oh yeah, okay, there you are. A little bit high, like that. Okay, maybe there. Then I lock this direction. Well now, these don't like to be run slowly. Well, yeah, and so I explain you now in advance what is going to happen here. When I approach that surface by moving this table like that, it will then stabilize, and at some point it kicks to the side. That is where our edge is found. And now I'm going to use also, when it kicks, I will lock the table right away. And then I reset my dials, and then I will do it again. Okay. And I'm running this about 500 RPM, so this will be somewhat noisy. Sorry about that. We are approaching now. There you are. Now it is exactly 3 millimeters away from that surface. Why? Because the diameter of this measuring surface is, 6 millimeters, half of that. Yeah. The fine scale is here. but for coarse tuning and for finding the millimeter we are approaching, well, it's easier to use this scale here. I will move this pointer to a suitable place. I will move it to here. Hopefully it can go to 0, yeah? Okay, let's put it there. I might be on your way, but yeah, there you are. When this indicator, this pointer is 0 and this one is also in 0 position, then we are at 0. And then I can move, for example, to 10 millimeters here. I approach it. I can see now it's a little bit over 9 there. And then I just move it here to the exact position. Here. So, this is a very fast way of moving things around here. Well, it's a Stone Age version of DRO. It works perfectly. These scales in this machine are really accurate. They are not just tape measures. They are this is actually surprisingly accurate to the last 40 centimeters. It agrees with this dial here. So you can really position. And now, of course, I have to rinse and repeat this for the Y direction. Here, under the machine, we have the scale for the Y. Well, it's in a little bit awkward place, but let me zoom you in here a little bit. Like this. Well, yeah, this is not the easiest thing to adjust. This is something that Saublin didn't do a proper job. I usually just choose some exact millimeter here. In this case, it seems to be 7, and try to not to move it when I tighten it in place. No, it's not in place. There. Yeah, now it seems to be. Yeah. There you are. Okay, now let's set up the coordinates for for the first hole. In this document, there you have it. It looks like the X direction is 23 and the Y direction is half of 50. So it will be 25. So let's make the X direction first. So I rotate here, hopefully this focuses, to 25. So it's 20 here. And then, oh no, not 25, 23. Oh, hey yo! 23. So that's quite near 23, and then we go here, and it's at 3. Went a little bit past. If you do that, you don't just come back like this, you have to come quite a lot, and then try again. Now it's quite exactly where it should be. And then I just lock the axe. There you are, locked. And then 25 for Y, okay. And so 7, that's 1, 10, that's 20, and about there. And then we need to go to this, I believe. Like that. Let's see. Looks to be that. Then I just lock the X. This is the X locking. And now it's on the correct place. Well, I can always come back to the original position. Well, now, this is, well, yeah, the surface finish is really nice. So let's see now. And I always check it like this, that it really touches everything, so then I just push it until it drops like that. Yeah. And then this one, well, let's see now. We should be around 19 point something. Well, it's 19.22. So let's advance this 0.5 millimeter. This knob here loosens the gips, and then I just put here 0.5 millimeter. 40. That's 0.5 millimeter. So, if my calculations now are correct, 19.20 something, so it should be 19.70 now, after this pass. It's 19.71. So our goal is 20.32. 20. I have to calculate this. 0.61 millimeters. Let's move this to 61. So when we move it to the 0, that's 50. 60 and 1. There you are. Tighten it. This will be the final pass. It should be 20.32. Wow. Now pushing it like that until it drops. And well, not too bad. It's okay. So the first hole is now done. Well, that hole became really good. The next hole will be around here. The document is stating that it should be 69.5 millimeters. So, I'll first unlock the X like that. And then 69. Oh wow. 69. 69. No, that's 69. 69 is here, and then 0.5 millimeter more. And it went past, so I have to take it back and There you are, half a millimeter more. Okay, there. And then I lock my eggs here. And this is just sanity check. Looks like it's in the correct place. That about concludes this episode of Vinogrid Machine. Quite a lot of material removal from this piece, and now I didn't make any mistakes. Yes! Well, it earns to be a little bit sharp, would I say. In Finnish language we say that you are sharp. Well, observant or whatever that is. Okay, anyway, succeeded to go through this thing without any mistakes. So, in the next episode we will be doing holes for attaching bolts on them, and also one hole at the top. It will be serving two purposes. I will reveal it back then, and then a smaller hole all the way through. Well, yeah, lubrication. Of course, you need to lubricate those bearings somehow. So, and it will be grease, not oil, grease. Grease because if you are working with paper, oil would be very bad if you have oil stains in your paper, unless you want to. Okay, well, maybe we also have in the next episode we also have name for that pony. My Little Pony. Please not that. I cannot use it. I would be getting copyright strikes right away. My Little Pony. Okay, yeah. So, in the next episode we will be doing those holes, and maybe the upper and lower plates. There will be another type of attaching issue with those work holding problem. But that will be in the next episode. Till then, bye!